going to solve a parallel circuit problem. So the first thing we do is to draw it. It says there's a 2 ohm resistor, another 2 ohm resistor, and a 3 ohm resistor connected in parallel. So the fact that they are connected in parallel tells me that we've got multiple loops, okay? And they're each going to get connected back to the battery there. With a 6-volt battery, find the current, voltage, and resistance across the battery and each resistor. So I'm going to go ahead and draw the battery right here. And then I'm going to do my first loop with the first resistor. And I'll get my second loop with my second resistor. And then the third loop with the third resistor. Okay. Label these. So this is a 6-volt battery. And this is a 2 ohm resistor. Move that all the way over to here. And then this is a 2 ohm resistor as well. That's right too. And then the last one is a 3 ohm resistor. We want to know the current, voltage, and resistance across the battery and each resistor. So we have to find the current and resistance here, voltage, current, voltage, current, voltage, current. So I'm going to go ahead and start with the challenging part here. I'm going to find the equivalent resistance. And it's a little bit more challenging in the series circuit, okay, because we have to look at the reciprocals. So 1 over the equivalent resistance is equal to 1 over the resistance of the first, which is 2, plus 1 over the resistance of the second, which is also 2, plus 1 over the resistance of the third component, which is 3. I like to change these to decimals. If you like working with fractions, great. You may more than welcome to continue to work with the fractions. I'm going to say 1 over the equivalent resistance is equal to 0.5 plus 0.5 plus 0.3 repeating. And I'm going to write it like that, but when I type it in my calculator, I'm going to type the 0.3 a lot of times. All right, so now, actually, I'm going to go over here. And I'm going to say 1 over the equivalent resistance is equal to 1.3 repeating. That's what I get when I add all of those together. So now I need to flip this, okay? Or you can think of it as you have to cross multiply. Okay, so we get, if we flip it around, okay, after we cross multiply, we get the equivalent resistance is equal to 1 over 1.3 repeating. And again, if I type that in my calculator, I'm going to write 1 divided by 1.3 repeating, and I'm going to get my answer, which is 0.75 ohms, okay? Or 3/4. If you kept it as a fraction, you would have got 3/4 ohms. Okay, so my equivalent resistance is equal to 0.75 ohms, or you could write it and say 3/4. So the next thing I'm going to do is go ahead and find what's missing here at the battery, which is the current. And to do that, I'll use Ohm's law. Voltage equals current times resistance. So 6 equals the current times 0.75. Divide both sides by 0.75. And I get the current is 8 amps. So now I need to go ahead and solve for the missing pieces for each of the components. So what's the same in a parallel circuit? Well, it's the voltage stays the same. Okay, this voltage is the same everywhere. Not the current, because they could go different speeds. So all right, voltage equals 6 volts, voltage equals 6 volts, and voltage equals 6 volts. Voltage drop everywhere is 6 volts. Then I'm going to go ahead and solve for the current using Ohm's law. 6 equals the current times 2, divided by 2. The current is 3 amps. Same process, and actually the same numbers for this one. It's another 2 ohm resistor. So again, we get a current of 3 amps. And then the last one again, Ohm's law. 6 equals the current times 3, divided by 3. This time the current is 2 amps. And then to check our work, okay, we can use Kirchhoff's current law, which says the current of the battery, 8 amps, is equal to the sum of the currents at each of the components. So 3 amps plus 3 amps plus 2 amps. So 3 plus 3 is 6, plus 2 is 8. So I get 8 equals 8, and we can be quite confident that we solved this parallel circuit correctly.